Hello friends, welcome to the channel Saurabh in Physics, and this is the second part of the video based on questions on limits and derivatives. In the first video, we have discussed the main formula of limits and the main formula of differentiation, or you can say derivatives. In this video, we'll be solving some important MCQs based on the same. So without wasting our time, let's start. And now let's discuss the first MCQ. And let me remind you, the questions done from the book that has been picked up is the support material provided by Government of and City of Delhi, and it's a very good book. So the first MCQ I'm writing it on the board, and you will be able to solve it quickly and solve with me. So this is the first question, and the question is, if L equals to limit x tends to 1, x to the power 4 minus 1 upon x to the power 3 minus 1, then what is the value of 3L? We have to find the value of 3L, and we have the equation is x to the power 4 minus 1 upon x cube minus 1, and the limit is that x is tending to 1. So we first break down the equation, that is limit x tends to 1. x4 can be written as x squared minus 1 upon, multiplied by x squared plus 1, and at the same time x cube can be broken down using the formula of a cube minus b cube, that is x minus 1 x squared plus x plus 1, and x squared minus 1 can be again written down as limit x tends to 1, x squared minus 1 is broken as x minus 1 x plus 1 x squared plus 1 upon x minus 1 x squared plus x plus 1. X minus 1 and x minus 1 gets cancelled out. So now what we simply do is we replace the value of x with 1 because x is tending to 1, and by doing this we get the answer as 1 plus 1 2 multiplied by x squared plus 1, and it is 1 squared plus 1, which is again 2. Again it's divided by x squared plus x plus 1. X squared is 1, then again 1 plus 1 plus 1, that is 3, and this is 4 by 3. This is the value of L, but we have to find the value of 3L. So for finding the value of 3L, we simply multiply 4 by 3 by 3, and 3 and 3 gets cancelled out. So our final answer is 4, that is option C. So amongst option A, B, C and D, that is 2, 3, 4 and then respectively, we get option C, that is 4, as the correct answer. So now let's move on to the next question. So our next question is limit x tends to pi sin x upon x minus pi is, we have to find the value of this equation when x is tending to pi. So first let's solve this. Then sin x, as you know, can be written as sin pi minus x, because sin x equals to sin pi minus x, and then x minus pi can be written as minus pi minus x, and the limit is x is tending to pi. Then from this minus 1 can be taken out as common, which is limit x tends to pi minus 1 multiplied by sin pi minus x upon pi minus x, and using the identity sin a upon a that we have discussed in the first part of the video, in which all the formulas were discussed, we get the value of this as 1. So it will become minus 1 multiplied by 1, and the answer is minus 1. So option C, minus 1, is correct. All other are 1, 2, 4. These are incorrect options because the negative sign, which is very important to keep in mind, otherwise you might take the answer as 1, but it's minus 1, that is option C. And this equation has been solved. So now let's move on to the next part. Now let's take a look at the next question, that is limit x tends to 0, x plus 1 to the power 16 minus 1 upon 1 plus x to the power 4 minus 1 is. Again we have to find the value of this equation when we are given that x is tending to 0. if we just put the value of x, then we'll get it in 0 by 0 form, that is infinity, but, or you can say not defined, but that will be invalid. So basically what I'll do here is I'll break down the numerator, not the denominator. So I can write this as limit x tends to 0, x plus 1 to the power 16 can be written as x plus 1 to the power 4 multiplied by to the power 4, and minus 1 can be written as 1 to the power 4 to the power, it can be written minus 1 to the power 4, and denominator is 1 plus x to the power 4 minus 1. And from this we can get this in the form of, if I consider this x plus 1 as y, let me just consider it, then it will be in the form of y to the power 4 minus 1 to the power 4 and y minus 1, which means it is in the form of y minus y to the power 4 minus a to the power 4 upon y minus a. Here a is the constant, or you can say 1, and same it can be written as, this can be also expressed as n, that is 4 multiplied by a, that is 1 to the power 4 minus 1, which is 4 to the power 1 cube, that is 4. So our option B, that is 4, is the answer to this question. It is a very simple one. If you remember this formula, then this can be solved in minutes, or you can even say in seconds. But by not remembering this formula, you will be wasting a lot of time in breaking this part down to the x to the power of x plus a, x minus a. You will be breaking it in that form, and it will take a lot of time. So this has been solved. Now next question we'll do it. So this is our next question, and the question is limit x tending to pi by 4 sec square x minus 2 upon tan x minus 1 is. Again we have to find the value of the equation. Basically the MCQs are based on these types of questions because they're easy to solve. So here it might be looking as a tough question, but let me tell you, it's a very simple one. What we do is we simply break the numerator, and the denominator we keep it unchanged. So sec square x minus 2 can be written as sec square x minus 1 upon tan x minus 1, and the limit is x tending to pi by 4, and sec square x minus 1, this part can be written as sec square x minus 1 can be written as tan square x minus 1 upon tan x minus 1, and again tan square x minus 1 can be written as tan x plus 1 upon multiplied by tan x minus 1. It will be tan x plus 1 multiplied by tan x minus 1 upon tan x minus 1. From this, tan x minus 1 and tan x minus 1 gets cancelled out. We are left with tan x plus 1 only. And tan x plus 1, we just replace the value of x, that is tan pi by 4 plus 1. Again, you know that the value of tan pi by 4 is 1, and it will be 1 plus 1. So the final answer to the solution is 1 plus 1, that is 2. Option C. Option C is the correct answer, that is 2. So the answer to this question was option C, 2. So now we have come up with a different question, and that is from the derivatives part, or you can say the differentiation part of this chapter. It is an interesting chapter and fun to do if you love this chapter, and I'll make it interesting for you to do this question. And as you can see, the question is y equals to sine 4x plus cos 4x. Then the differentiation of y with respect to x is what? The options are A 4 sine cube x plus 4 cos cube x, B 4 sine cube x minus 4 cos cube x, C minus sine 4x or D 0. Before we solve this question, let me just give you some few tips on differentiation. On differentiation, the first tip is dxn with respect to dx when differentiated is nx n minus 1. The second tip is differentiation of sin x with respect to x is always cos x. And the third tip is differentiation of cos x with respect to x is always minus sin x. With these tips kept in mind, our question will be solved very easily. So please note down these 3 points and I'll erase it so that we'll be able to solve the question. So dy by dx, that is d sin 4x plus cos 4x by dx. So sin 4x, it can be written as, if we consider this as x to the power n, then we have n is 4. So we write down 4, then sin 4 minus 1x, because it is nx n minus 1. Using this formula, I have differentiated this part. And then one thing is left, sin x should also be differentiated. So it will become cos x. It will not differentiate on the basis of power, but simple differentiation of sin x, not sin 4x. So sin x will be differentiated as cos x. And for the second part, cos 4x, again the same thing, 4 cos 4 minus 1x, and the differentiation of cos x is minus sin x. So if we simplify this, we get it as 4 sin cube x cos x minus 4 cos cube x sin x. From this, we can take 4 sin x cos x common. So it will be 4 sin x cos x multiplied by sin square x minus cos square x. This is sin 4x, not sin to the power 4, it is minus sin 4x. I just gave you this hint because otherwise you might get confused. Then 4, it will be 2 multiplied by 2 sin x cos x, and if we take out minus common from here, I'll put the negative sign in the front. It will be as cos square x minus sin square x. 2 sin x cos x, that is sin 2x, and the minus 2 will be in the front again. And cos square x minus sin square x is cos 2x. I am solving the remaining part are here, so you can note it down from this here. So from this part, again minus 2 sin 2x cos 2x. This can again written as minus sin 4x. And this is the final result. You can see the final answer when this part is differentiated with respect to x. That is, option C is correct. It was a nice question to do this one, as we're different from the limits part, and this takes a bit of calculation, but if you know your trigonometric ratios and identities very well, then it can be solved easily. So let me give you just one remembering point, that when you step out to solve the questions of derivatives, just remember this thing, that you must have a good command over your trigonometric identities, because they will be very handy when you are solving these questions, and you have to learn your formulae also very well. as calculus is an important part for the competitive exams, as well as if you are doing your 12th class, then you know in boards it is a matter of 35 marks. So calculus cannot be ignored just because it doesn't carry much weight in class 11. But for class 12 and other competitive exams, these formulae will help you a lot. Otherwise, you will not be able to solve your paper at a very quick rate. So after this, now let me say that MCQs have been solved. Now we'll be moving on to 1 markers, or you can say the short answer type questions. So let's solve them also. So this is our next question, that is the 1 markers, and the question is, find the value of limit x tends to 0 when 1 plus x to the power m minus 1 is divided by 1 plus x to the power n minus 1. So for this, we simply divide both the numerator and the denominator by x. After this, now in this, if I add 1 and subtract 1, the meaning will be same. And for this below one also, if I add 1 and subtract 1, then again it is same, because 1 and minus 1 from both will get cancelled out. And then I take these in brackets. So here it is, from this part and this part, they can be seen as 2 different parts. So this can be written as m 1 to the power m minus 1 upon n 1 to the power n minus 1, and 1 to the power any number is 1, so it will be m by n. This is the solution, and it was done in seconds because we remembered the formula xn minus an upon x minus a is equal to na n minus 1. So that formula is very handy and very simple. So please remember this formula especially, as it will help you a lot through this chapter. So moving on, now let us discuss the next question. So guys, this is our next question, that is, find the value of limit x tends to 0 when the equation given is sin 2x plus 3x upon 2x plus tan 3x. For this, it is not a very tough question, but it can be solved easily if we have some basic concepts in mind. First, I multiply the numerator and also divide by 2x, which will be 2x upon 2x multiplied by sin 2x plus 3x, and similarly I do with the denominator. Here I multiply and divide it with 3x. 3x upon 3x, 2x plus tan 3x, and the limit is x tending to 0. Now first with sin 2x, it can be written as 2x sin 2x divided by 2x, and for 3x, 2x and 2x will get cancelled, so I directly write it as 3x, and for the denominator 2x will be remaining same. For tan 3x, it will be 3x tan 3x by 3x. This whole part becomes 1, and this whole part also becomes 1, using the identity sin x upon x is equal to 1 and tan x upon x equals to 1. So from this we will get limit x tends to 0 2x plus 3x upon 3x plus 2x, and this can be cancelled out, so the final result is 1. So the solution for this equation was 1. Similarly, now we move on to the next question, that is also based on a trigonometric identity. So I'll erase this one and we'll move on to the next one. So this is our next question. Limit x tends to 0, 1 minus cos 2x upon 1 minus cos 4x we have to find this value. So without wasting time, let's start the solution. It is limit x tends to 0, 1 minus cos 2x using the trigonometric identity. It is minus 2 sine square x upon minus 2 sine square 2x, because 1 minus cos 4x can be written as 1 minus cos 2 multiplied by 2x, and 2x can be considered as a whole part. Minus 2 and minus 2 gets cancelled out. Then limit x tends to 0, sine square 2x can be, sine square x remains the same, but sine square 2x can be written as 4 sine square x cos square x. Sine square x and sine square x also gets cancelled out. Now we simply replace the value of x with 0. It is 1 upon 4 cos square 0. The value of cos square 0, as we already know, is 1. So the final answer is 1 by 4. This is the solution to this question. Note it down and we'll move on to the next question. Now coming to this question, it is based on differentiation. And the question is, if y is equal to sine square x cos cube x, then what is the value of dy by dx? So before solving this, let me just give you some important tips. First, we will be using the product rule. The product rule states that if y is equal to fx dot gx, comma, then differentiation of y will be differentiation of fx multiplied by gx plus differentiation of gx multiplied by fx. This is the statement of product rule, and this is the formula that we are going to be using to solve this question. So if you note down this formula, in this, let me remind you, fx is sine square x and gx is cos cube x. Now keep this in mind. I'll erase this one and we'll now solve the question. So first, that is differentiation of dy by dx, it will be d sine square x cos cube x by dx. That is, cos cube x will be same, but sine square x will be differentiated, and plus sine square x will be same now, and cos cube x will be differentiated. So for this, cos cube x remains the same. Now for the differentiation of sin x, it will be 2 sin x cos x plus sin square x will remain same. Cos cube x differentiation, it will be 3 cos square x minus sin x. From this we can take cos square x and sin x common, which will be sin x cos square x, and it will be minus 2 cos square x minus 3 sin square x. This is the final result after this part has been differentiated. This is the final result of the solution. Please note it down. It was a very small question, but for this, the keeping in mind of product rule is very important. Otherwise, it will not be solved. And the methods of differentiation: first, the power comes in front. Then from the power, 1 is subtracted, and then sin x and cos x both are respectively differentiated to cos x and minus sin x. The differentiation tips should be kept in mind. Otherwise, this question will not be solved. So I erase this and I'll write the next question, which is also based on product rule. The next question is y is equal to sine 2x cos 3x. Then dy by dx is equal to what? The same question, and here again we'll be applying the product rule. So dy by dx equals to d sine 2x cos 3x upon dx. So it will be cos 3x will come out same, d sine 2x by dx, and in addition it will be sine 2x will be same and d cos 3x by dx. So solving this, it will be cos 3x multiplied by sine 2x has to be differentiated, so it will be cos 2x dot, first sine 2x is differentiated as cos 2x, and then again now 2x has to be differentiated, so 2x will be differentiated, so b 2x by dx, and for this the answer will be 2 multiplied by 2. And similarly for this one, sine 2x cos 3x has to be differentiated, so cos 3x will come out as minus sine 3x, and differentiation will be done for 3x, that is d 3x by dx, that is 3. So the final result will be 2 cos 3x cos 2x minus 3 sine 2x sine 3x. From this it can also be written as 2 cos 3x cos 2x minus 2 sine 2x sine 3x minus sine 2x sine 3x. This it can be written as 2 cos 2x plus 3x minus sine 2x sine 3x, and the final answer will be 2 cos 5x minus sine 2x sine 3x. This is the final answer to the solution of differentiation of sine 2x cos 3x. If we wanted, we could have just left it out here, but to make the value look small, I just applied some trigonometric identities and I got this as the final answer. If you leave it here also, the teacher or the examiner who is taking your sheet will give you the full marks. So that's all for today's video. In the next video, I will be discussing with you 2 markers and some long questions based on the same chapter, that is limits and derivatives. Till then, thank you and goodbye.